All right, welcome to this session on how we can use the iScience series to plan effective primary science lessons using an approach which MC calls it simply 3Cs and 1E. I want to share with us the pedagogical approach used by MCE, 3Cs and 1E. And I want to focus on why capturing interest is so important for us science teachers and how we can help students construct understanding. At the same time, help students consolidate their learning. And if we are teaching science and we want to make it an enriching science lesson, what does that involve? The main objectives of this webinar really is to use this pedagogical approach, 3Cs and 1E, together with the iScience series, how we can then design and deliver exciting science lessons. Right? So that's the main aim of our webinar. When you sign up for this webinar, you will notice the publicity says we can simply use the iScience series to simplify, engage, and inspire, teaching science with ease. So it's really very simple. Just remember 3Cs, 1E. Right? It's very easy to use because the first C, which is capture interest, is kind of like what you do at the beginning of your lesson. Right? As a lesson introduction, that's capturing interest. The second C, constructing student understanding, is what you do to engage them when they are studying, right? And the last C, consolidating learning, is what you do at the closure of your lesson. So simple, engaging, easy to use pedagogical approach. 3Cs, 1E, all right? That's very clear for us. So let's start. Why do we use the 3Cs and 1E? Because it is MCE's pedagogical approach. And when we understand the pedagogical approach, we as teachers take on the role of lesson designers. Now, teachers as designers are not fully appreciated. So I like this quote from John McLean, which says, "The complexity of design work is often underestimated. Many people believe they know a good deal about design. What they do not realize is how much more they need to know to design well with distinction, refinement, and grace." So my hope is that as I share with you a simple lesson planning pedagogical approach, 3Cs and 1E, that you as fellow educators will become good designers of your lesson. So becoming a good designer is more worthwhile than having good designs. The resources that you have, including MCE iScience series, are good designs. They're being specially planned for you to teach science in an exciting way. But today, in this webinar, as we understand the design principle behind it, that will make you become good designers. And that is far more worthwhile than just having a good resource. Now, why is that so? In a few moments, I will unpack it for us. But here it is in a nutshell, the 3Cs and 1E. You can see the first intro to the lesson begins with capturing interest. And we're talking about capturing student interest that is related to the big idea of your lesson or the big idea of the topic or the theme. And that moves on to helping students construct their understanding. Now, you can use different methods, which I'll share with you, but we want them to grow in their understanding of the science concept. And then, as you close the lesson, we help them consolidate their learning. Over and above this, if you want to provide an enrichment that goes beyond the syllabus, that will really help you address students of different readiness, different abilities, right? Different interests. So 3 C's and 1 E in a nutshell. We all understand that if I want to enhance student learning, I need to capture student interest. But the bigger question behind this statement is why? Why is it so important to capture student interest? Now, I know you have many reasons, and probably if I ask you to type in your reasons in the chat, you're going to give me a variety of reasons, right? Why that is important. But I just want to suggest maybe one reason, and I think it's a major reason, why to enhance student learning, teachers need to capture student interest. And the reason is this. Because I don't teach science. I teach students science. Now, just in case you can't appreciate that, that's a world of difference, right? Now, I'm a professor of teacher education at the National Institute of Education, where we train pre-service teachers in Singapore. And whenever I go to my pre-service teachers, I tell them, I don't teach science. I don't teach mathematics. I don't teach English language. By which time they're scratching their head and they're asking me, Prof. Ho, what do you teach? And then I tell them, I teach students science. I teach students mathematics. I teach students English language. You see, here's a world of difference. Because if I were to teach science, it's very straightforward. It's very simple. I just go blah, 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 blah. You know, whether my students understand, whether they are engaged or not, that's not my problem because I'm teaching a subject. But if I teach students science, it's going to be challenging because I have some students who are extremely interested in this topic. I have some students who are not. I have some students who love to do some experiment with hands-on activities. There are some students who are not. I have some students who love to ask questions and some students who are not. You see, so it's a world of difference. When you don't teach a subject, you teach students the subject, your goal is to help them construct understanding. So to start off, capturing interest is key in your lesson planning. Because if you want your students to learn and to enhance the student learning, you need to capture student interest. Capturing interest. The key word is reach. If you can't reach them, you can't teach them. You got to make the connection. If you don't have the connection, they are not going to be with you. And you know what's the reality today? The reality today is students take less than 10 seconds to see if they can be engaged by you. So it's so important as we begin this iScience series on how to design effective and exciting science lesson that I start with the first C, in our pedagogical approach. Capture interest. Reach. Because if you can't reach the students, you can't teach the students. And reaching the students is making the connection, getting them interested. And there are ways to do it, but it's getting them interested. Now, I want to add one more point to it. It's not just getting them interested in that topic, but for you as a teacher to activate and access your students' prior knowledge about that topic. Okay, getting them interested in the lesson is fundamental to effective teaching. But in our first C, when we capture student interest, we also want to learn something about their preconception, what we call students' prior knowledge about that topic. So how do we do that? Now you have the series, you have the iScience series, so there are resources available for you. If you look at a book carefully, there are questions to help you that you can pose to your students to help them in their learning, right? So these are questions which are listed in the chapters, and you can use that book feature of interesting questions to pose to your students to engage them. Let me give you some example. So this is your iScience series. This is primary 3. This is chapter 3, the world of materials, page 65, right? And if you look at this page and you look at the pictures, and there will be questions there. And the questions, look at the pictures. What is wrong with the material used to make each object? Okay, so we have questions as part of the book features to help you so that you can ask your students interesting questions to get them engaged, to capture their interest. Now, if you find that the pictures are too static and you want to make it more interactive, I'm sure you can bring in the materials into class. All right, the materials into class and ask, if you use that material for such and such an object, would it be suitable? Why or why not? And as they share with you, as they explain to you, all right, then you will be able to activate and assess their prior knowledge. You see, that's the thing that we want to do. And that is to really activate and assess their prior knowledge. So this is an example from chapter 3, the world of materials. And you can see that there are pictures there. But as I've said, if you find the pictures too static, bring in the materials and ask them, if such and such a material is useful to make such and such an object, why or why not? And as they share with you, then you will be able to activate and assess their prior knowledge to see if they understand the concept, all right, that is required. Okay, so let me move on. So use pictures, and we can ask questions that have been listed in the chapter to guide you, or you can ask an alternative questions such as, what do you see? So I continue with chapter 3, the world of materials. Now in this picture, you can see the picture below shows a living room. The objects in the living room are made of different materials. So you can ask them, what do you see? All right. And then they can see, I see a door, I see a sofa set, I see a table, I see curtains, you know, but we are focusing on materials. So what are these objects made of? Right? So they can say the door is made of wood, you know, the curtain is made of cloth, fabric, you know. So as they tell you what they see, and what materials these objects are made of, you can activate and assess students' preconception. That means you get to know their prior knowledge about this topic, right? And this is important because as they share with you, their prior knowledge will indicate how much they know about this topic of materials, whether they're using the appropriate scientific terms, whether they know whether these materials are useful as materials for certain objects, how suitable they are, right? So that's important for you. So capture interest by reaching out to them, and you don't have to reinvent the wheel. The good designs, the good resources that you have, MC's iScience series has embedded in each chapter book features that you can use. All right. So to start with, there are questions in there that you can pose to your students to help them answer. And as they answer, you know what prior knowledge they have about that topic. If you want to use an alternative question, I put it here. What do you see? All right. So this is just an example. Here's more example. So this one is from Primary 6, Chapter 3 on the topic of forces, page 45. And again, you can ask the question, what do you see? All right. So in the book itself, there is a picture. It's difficult hanging clothes when the wind blows with such force. Right? So what do you see? Now, if the students give you an answer like the clothes flew away, okay, there will be an appropriate answer. Now, if the students give you an answer, force, what do you see? Force. Then it needs some explanation. All right. Although we say that the wind blows with such force, but you can see the effects of the force. Right. So you got to ask alternative questions. What do you see? Now, this is a carefully designed question rather than asking, which most of us teachers do very often, can you explain? Right? And when you ask, can you explain? Sometimes the students tighten up because they don't know the answer and they're very scared and they cannot explain. And they'll start to say, I don't know. And when they say, I don't know, usually we teachers come in and help them and we explain it on their behalf, right? So most of the time, we are teaching the topic, we are explaining the concepts, we are doing all the work, and no wonder at the end of the lesson, we are the one feeling very tired. We want them to be doing the work. We facilitate their learning by capturing their interest. We reach out to them because I'm not teaching the subject, I'm teaching my students the subject. And we do that by showing them exciting visuals, even bringing materials to the class, real materials to show them, let them feel and touch, and then pose interesting questions to them. Because when they answer those questions, they show us how much they know or do not know about the topic. We call that student prior knowledge, preconception, right? So as part of the book feature, questions are listed there. But you can ask an alternative question. What do you see? Okay? Now, so I'm going to interact with you now a little bit. Okay? So I'm going to ask you a question. What is a force? Now, this, you know, this is an MCQ question. So option 1, a push or pull. Option 2, you can see F subscript R, that means the resultant force equals to mass, which is M, times acceleration, which is A. You can see option 3, F resultant force equals to mass bracket the final velocity v2 minus the initial velocity v1 divided by time t. And you can see 4, option 4, all of the above. Okay? So I'm going to give you some time to think about this as you reflect on what do you think is the correct answer to this question, what is a force? Now, I would want to say, well, it really depends, right? What does it depend on? It depends on which level you are teaching, right? Can I share with you a story, a real life story of what happened in Singapore? The primary school teacher went into the class and asked exactly this question, what is a force? All right? And all the students raised their hand. You know, primary school students, they are very enthusiastic. And so the teacher called on this boy, and this boy answered the teacher, a force is a push or pull. And the teacher was very happy. The teacher told the boy, correct. And the boy was very happy. And he went home and he studied very hard. And he passed his primary school examinations with good grades. And so he was promoted to a secondary school. And in the Singapore context, our science curriculum is what we call a spiral curriculum. That means the topic on force will be revisited at the secondary school level at a deeper level. And so the secondary school teacher came into the class and told the class, today we're going to learn forces. So what is a force? And the boy raised his hand and the boy said, sure, I know. And so the teacher said, yes. And the boy said, a force is a push or pull. And the secondary school teacher says, correct, but. Now, when the teacher says correct, but, that means it's not correct. Because the but negates the first part, right? So the secondary school teacher told the boy, that's primary school. Now you're in secondary school, and I will teach you resultant force equals to mass times acceleration. FR equals to MA. And so the boy learned that, and he went home and he studied very hard, and he passed his secondary school examinations with good grades, and he went to a junior college, and the science curriculum spiraled. And the lecturer in the junior college came into class and told the class, now class, we're going to learn forces, kinematics, and I'm going to ask you what is a force. And the boy raised his hand and said, sir, I know. And the lecturer said, yes. And the boy said, F resultant equals to mass times acceleration. And so the lecturer told the boy, correct, but that's secondary school. I can see Abigail laughing. Okay, that's secondary school. Now you are in a junior college and you will learn that resultant force equals to mass M bracket final velocity v2 minus initial velocity v1 divided by time t, which is rate of change of momentum. And so the boy studied very hard. In fact, this boy studied all the way from primary school to university, and he passed all his major science exams with good grades. But I can tell you something about this boy. He doesn't understand anything about forces. How do I know? Because I'm that boy. When did I understand forces? When I became a teacher and I had to teach the concept of a force, right? And I learned that a force is not a property, characteristic of a single object. Forces arise out of interaction of two objects. You see, this definition of a force is a conceptual understanding. F resultant equals to MA is a formula to calculate the resultant force, right? So you can see that it is really not so easy, even though the students can pass all the exams with good grades by doing all the calculation through all the practices, but to have the conceptual understanding in science, which we science educators demand of our students, is a challenging task for the students, okay? So what we need to do using MC's 3 C's and 1 E, the first C is capture interest. Reach. If you can't reach them, you can't teach them. And reaching them is not just getting them engaged through good visuals in your iScience series, through props that you bring in, through experiments that you demonstrate, but reaching out to them, engaging them is also asking good questions for them to answer, to share, and in that way, you activate and assess students' prior knowledge, their preconception. So that leads us to second C, construct understanding. Reflect. Reflect. Reflection is not a luxury. It is a necessity. If you want to learn something and learn it well, you have to take time to think and reflect about what you are learning. I hope in our very short 1.5 hours webinar, I can role model for you the 3 C's and 1 E. If you have not realized it, I've already done the first C, which is capture interest. Right? I've shared with you why using the pedagogical approach is so critical. Because the principle is, I'm not teaching a subject. I'm teaching my students the subject. And I pose a question to you. What is a force? And I share my own life story as a student with you. How from a student to a teacher, I have gained the conceptual understanding of a force, more than just being able to calculate using formulas. So I've captured your interest. I've given you time to reflect as I asked you that question earlier on, what is a force? So my reflection component of my lesson planning is spread out throughout the whole webinar. It is not something that you do at the end of it, right? But it is done throughout. So reflection is a necessary part of learning. So I hope in your lesson plan, as you use the iScience series, you remember the capture interest, the first C. You remember the second C, construct understanding. And you remember this keyword, reflect. So the first C is capture interest. The second C is construct understanding, right? And give your students time to reflect, to think about the questions you pose. And this comes in the second part of your lesson plan. You know, your lesson plan, as I said, this webinar is simple, it's easy to use, and hopefully it's engaging for you and for you with your students, all right? It's simple enough because if you think of a lesson plan, you have the introduction, which you use the first C, capture interest. You have the body of your lesson planning, which is constructing understanding. You give them time to reflect. Now we are into this second part, right? Developing the conceptual understanding in science. Give them time to reflect. So I'm going to give you examples. So since I'm on forces, use the iScience series. So this is Primary 6, Chapter 3, page 50. All right. And in that page, you'll see that there's some write-up about gravitational force. All right. Gravity. You can see that other types of forces are also shown. Elastic spring forces with visuals again. But as I said, if you want something hands-on, you can bring in the props into your classroom. And notice the book feature, right? Notice that there is a box with a key, and that means the key idea, all right? So what is a gravitational force? This is the one, right? So you can see the book feature is there. So this is what we want our students to take away. This is the conceptual understanding. That gravitational force or gravity is a force of attraction between objects that have mass. So an object has mass, and this is the attraction of the object by Earth, right? So you can see the second point, objects on Earth have weight because of the gravitational force between them and the Earth, right? So that's, and you can ask your students, what's the difference between mass and weight, right? The object has mass, but weight is a gravitational force. Weight is the force, right? So of course, if they go on later on in higher level, they will learn about scalar quantities and vector quantities, all right? But at this level, they learn about types of forces, gravitational force, and what that means. And so you give your students time to think about it. And you can also ask them if they have questions that they would like to ask, right? And as they ask their questions, you can also address their questions. A force is a push or pull. And as I've given you, the definition is a force is not a characteristic, it's not a characteristic of a single object, but it is actually arising from interaction of two objects. So here you can see an object and Earth interacting, giving rise to gravitational force. Okay, and this is part of the book feature. Again, this is a key concept. So you're the little key there. So this guides you into focusing on the concepts that the students require to learn. So you want them to help the students construct their understanding of this concept. You can ask how many types of forces are there, all right? And in the book itself, they will learn a couple of others. Elastic spring force, frictional force, and magnetic force, okay? Now, also in the book, in your design, you have a chapter wrap up. So you can see here, a force is a push or pull. That's the conceptual understanding at the primary level. A force has the following effects, right? These are effects of forces, and these are different types of forces that they will learn. So this is kind of a chapter wrap up, a summary, and these are the key concepts that you want your students to learn. Each of these type of forces are defined. Gravitational force is the force of attraction between an object that has mass and an object on Earth has weight because of the gravitational force between the object and the Earth. An elastic spring force is the force exerted by a spring, whether it is stretched or compressed. And the spring exerts this force on whatever is stretching or compressing. So it goes on. So these are all given to you. So you don't have to start from scratch. As I've said, the iScience series is a good design. Today, I'm sharing with you the pedagogical approach of 3 C's and 1 E to help you become good designers as you plan your lesson. Okay, so these are the concepts there. It's there in your book. So this is put in the form of a diagram. All right, so these are called contact forces vis-a-vis non-contact forces. This is not in the iScience series. You can easily access some of this information online. So this is something additional, right? Just in case your students might ask you, what's the difference between a frictional force and a gravitational force? So you can see a frictional force that is contact. Gravitational force is what is termed as non-contact forces, right? So these are additional information that you can share with your students. Okay, so what we do in constructing understanding is really to ask thoughtful questions. Ask the students thoughtful questions. Again, you don't have to start from scratch. It's part of the book features. The questions are there. The visuals are there. The key concepts are there. Look for the box with the little key. Those are important key concepts. They're all there. What you need to learn now is to help you plan your lesson by using 3 C's and 1 E. And that is the design principle behind it. Okay. Now, let me give you more example. So this is, again, primary 1, chapter 4 on food. All right. And food is something we all appreciate. we love to eat. And I must say that Indonesia is very nice cuisine. I love Indonesian food, So food is something we all look forward to. Again, you can ask alternative questions. What do you see? Okay, and it's all pictured there with the names given to it. And this is a category of carbohydrates. You can see that rice, bread, cereal, and chocolate give us energy. Okay, and then you can go on to the next group, right? You can see, what do you see? Again, you ask them, what do you see? Chicken, fish, milk, and cheese help us grow. All right, and you can go on to the next group. These are all on fibers. Water, vegetables, and fruits keep us healthy. What do you see? Okay. And so we are introducing them to different group types, like carbohydrates, proteins, fibers, and all that. Okay. Now, then you can follow up with another question. What do you think is going on? Okay. So this is the construct understanding. The second C. This is giving the students some time to think about what they are learning. All right, so you use the same capture interest with the visuals, with the questions, you ask thoughtful questions, but now you give them time to think, to reflect. And reflection is part of your lesson throughout. And now you ask another alternative question. What do you think is going on? Okay, if we eat too much sweet food, it can make us sick. Right? What do you think is going on? Or if we eat only one type of food, right, we may not be as healthy as we want to be. What do you think is going on? Okay, so you give them some time to think, and then you let them explain to you. Okay, so final question you can ask is, what does this make you wonder? Now, I must say that this is not an easy question for both teachers and students. If you're interested in this, what do you see? What do you think is going on? What does this make you wonder? This is a teaching strategy as part of what we call thinking routines. So you can always Google thinking routines. This is part of the 21 thinking routines, one of the strategy. So what does this make you wonder about different types of food for different purposes and the effects these food have on our body? Okay? So this is called the thinking routine. See, think, wonder. This is especially useful if you are introducing a new chapter. So after you have engaged them, right, you have captured their interest, you are now constructing understanding with your students. This is an alternative that you can use. You can ask them, what do you see? What do you think is going on? What does this make you wonder? Notice these questions are carefully selected and worded. None of these questions ask, can you explain? Because as I've said, that's quite frightening for the students. Right? But if you ask it this way, what do you see? Unless they are blind, they can see something. Right? Yeah. And some people say actually blind people can see better than those of us with sight. Right? So it's not so frightening. Right? But that's something you can use. Thinking routines. If you're interested, you can Google and get more information on that. Now, let me come to the last C, which is the third C, consolidate learning. The key word here is recode. The best materials are those that you develop yourself. Now, I I can't see you fully, but I wouldn't be surprised if some of you are taking notes, which is very good. I commend you on that. Okay, some of you are probably typing out instead of writing it out. That's equally fine, whether it's digital form or hard copy form. Some of you perhaps are doodling, you're drawing some diagrams, you're making sense of it, which is very good. I encourage that. Some of you are doing concept mapping, very good too, right? And that's your own materials that you develop for yourself. And that will be the best material. Because as you do that, you are doing actually what I call recoding. And recoding is simply processing information presented to you. If you just go through this webinar just to listen, that's good, right? And respond, that's interaction, that's good. But if you add on to your interaction some form of note-taking, some form of concept mapping, then you are doing more. You are doing recoding, okay? So that's the part that you want to encourage your students to do as you conclude your lesson. First C, capture interest. Keyword, reach. Slogan, if you can't reach them, you can't teach them. Second C, construct understanding. Keyword, reflect. Slogan, reflection is not a luxury. It is a necessary part of learning. Third C, consolidate learning. Keyword, recode. Slogan, the best materials are those that you develop yourself. How do you recode? These are some suggestions. You can ask students to draw a symbol. You can ask students to summarize what they have learned in a few sentences, or using certain keywords, right? Like gravitational force, frictional force, magnetic force. You can ask them to give examples. You can ask them to compare and contrast frictional force with gravitational force. All right, carbohydrates with proteins. So you can ask them to do a few of these things. Now you let them do all this by providing them with some worksheets. Now I'm a firm believer of worksheets. And for me, worksheet simply means what the students use in class during the lessons for the purpose of recoding. That is to process information presented to them, right? Now, some of these you can, again, adapt it from the iScience series. So I'm going to give you an example. So this is an example of a concept map, which you'll find at the end of chapter 4 for P1, as we used the example earlier on food for different purposes, for energy, for growth, for keeping healthy, with different examples. Okay, so they have seen that. So this is the completed concept map, which is given to you in the iScience series. But as you teach your lesson, you may ask the students to construct their own concept map, because the best materials are those developed by your students themselves. Right? Now, their initial concept map may not be complete. It may not be accurate. That's fine. That is part of the thinking, the reflection, and the consolidating. Right? The categorizing, the summarizing to get to this point. Okay? But remember, consolidate learning, recode. Let students process information presented. Let me give you another example. We talked about materials earlier on. This is primary 3. So here's a concept map again. Materials with different uses, examples. based on certain choices, depending on the properties, the physical properties that will suit the use of that object. Okay. For example, if you use an umbrella, probably the canopy of the umbrella, you want to use something that is water resistant. Right? If you use paper, not that it's not possible, because in the olden days in China, they also have so-called paper umbrella, but the paper is treated with certain materials. There's a layer of wax, right? Because you can't use paper. The paper will get wet, it will collapse, right? So that's a wrong use of the material for an object like an umbrella. Okay, so this is again a concept map. Now let me show you one more example. This is on light, right? This is primary 2, chapter 4 on light. Now light helps plants to make food. Light helps us see things. Light is given out by the sun, fire, lamps, torch. Light travels in straight line. Light bounces off things and enters our eyes. Light, when blocked, forms shadow of different shapes and of different sizes. Okay. Now, I'm going to construct understanding. I'm going to ask you a question and we're going to interact together. This is concept map number 3. The previous concept map, this is concept map number 2. And this is concept map number 1. So I've shown you 3 concept map. 1 is this one. 2 and 3. Out of these 3 concept map, which concept map is the odd one out? Okay. Well, let me, as I've said earlier, number 2 is the odd one out, because if you look carefully at number 2 and you look at number 3 and you look at number 1, right? You see these concept maps, they all have arrows, all right? And the arrows are followed by what we call linking words, right? Concept map number 1, you can see that it says there, food for energy with examples, okay? But if you look at number 2, you see arrows, but you don't see the linking words, right? Of course, you can redraw that. You can say materials used, all right, for, and then you can put down different objects, okay? Now, if you look at number 3, again, you see the arrows with the linking words. So there are 2 features of concept maps that are very important. Number 1, concept map shows the interrelationship among key ideas by using arrows, through arrows. That's number 1. You can see the linkages there. They're okay. Number 2, these arrows have linking words. A lot of people miss that. Okay, so the arrows are linking words. Yeah. So number 2 is the odd one out. Okay, well, let me move on. So I come to the final letter now, E. So we have 3 C's and 1 E. Let me summarize. The first C is capture interest. Yes, thank you very much. Capture interest. The keyword is reach. Right? If you can't reach them, you can't teach them. The second C is construct understanding. The keyword is reflect. Reflection is not a luxury, it is a necessity. The third C is consolidating. Yes, thank you. And the keyword is recode. Process information presented. The best materials are those you develop yourself. Now we come to the last one. This is over and above your syllabus. If you want to enrich, because you have students of different types, right? You have some students who are very good in science and you also want them to learn more. So this is part of enrichment, going beyond the syllabus. Okay. So let me share with you part of enrichment, how you can do that. Now, again, it's part of the book feature. If you look at the iScience series, you will see this part here that says in-depth knowledge that is not for exams. Right? So it's over and above what is required by the syllabus. It's something that is useful for them to know if they are really interested. And in your enrichment part, what we normally try to do is to mirror the real world problems. Right? So let me give you an example. This is iScience, Primary 2, Chapter 5, Hearing Sounds. Hearing sounds. So you can see that we hear different sounds every day. What sounds do you hear during recess? Questions that have been in there for you to ask as part of capture interest. What sounds do you hear at a bird park? All right. Sounds can be soft or loud. Okay, so these are questions that have been in there. Now let's do a little bit of interaction. Let's try to produce this sound S within the phonic S. So what I'd like you to do is to place your thumb and your index finger on your throat, somewhere near your so-called Adam's apple, okay? Place it near there and try and produce this sound S. Now, what do you feel at this point of your throat where you have your thumb and your index finger? Do you feel any vibration? You shouldn't, okay? If you do, I'm not sure about your anatomy, okay? You shouldn't. But you know, sound are made when there's vibration of air particles. So where is the vibration? So you see, you're asking questions. You are doing here, in this case, an activity, a simple activity, right? Where students can do it. You're capturing interest. You're asking thoughtful questions. They are responding to you. And when they respond, you know whether they know about the topic or not. Right? Because if they use words like vibration of particles, air particles, sound, okay? You know, all right? If they can use, like, for example, where you have your sound is produced, the source, right? The air coming up from a diaphragm passes through, all right? Your mouth, all right? So things like this. Okay. Now with your thumb and your index finger at the same position, let's produce another sound. Okay? So let's try. Let's produce now this sound Z. Zzz. Now what do you feel? Zzz. Can you feel vibration here now? So earlier on, the vibration was in your oral cavity, right? Somewhere between your tongue and your upper palate. And now you can have some fun. You can alternate between S and Z. All right, and you can feel the difference. So this is something on sound. This is going over and above, all right, what is required by the syllabus. But the whole idea of science is nothing more than a refinement of everyday thinking. Because as part of the enrichment, we really want to mirror real-world problems and see how scientists think and work. And so in the example I've just given you, now notice the question I asked, what do you feel at this point? You see, I never asked the students, can you explain? So what do you feel is a variation of the earlier question, what do you see? And in the topic of sound, in the textbook itself, they ask you, what do you hear? What sounds do you hear at the bird park? What sounds do you hear during recess? You see? So these are good questions, thoughtful questions that you can ask. So how do scientists think and work? As part of enrichment, we help them understand how scientists think and work in the real world. Where in the real world, scientists work on solving researchable problems. They make careful observations. So we do all that just now. Although this is not really a researchable problem, we already know the answer, right? But you are making observations, right? You're trying it out. And then you ask questions. That's how scientists think and work. They ask questions. They repeat their experiments. They collect, analyze, and interpret data. And then they draw conclusions. And then they work with other scientists. Now, the next slide I'm going to show you has the same information, but presented in a different way. How is it different? It's in the form of visuals. Why do we do it like this? Because in enrichment, we cater to students of different interests, different abilities, different readiness, different learning preferences. Some students would like the bullet point. Some students would draw and make a symbol. The best notes are those that the students develop themselves as they consolidate their learning. That will be the best notes because they're processing information presented and then they are learning from their own notes. Okay, this is one website that you need to take note, especially if you use Marshall Cavendish resources. This is mceduhub, the online MCE's platform. Okay, so www.mceduhub.com. Right, I'm sure you would have your user ID, you would have your password, and with this, you can access resources that's been there. Okay, and MCE provide, as I've said, wonderful, good design resources. But today in this webinar, we take you behind the scene and we share with you the 3 C's and 1 E. And it's simple to use, it's easy to use, because the first C, you can use it as part of your lesson introduction, capture interest. And in your textbook, there are already book features there that you can use. The second C is really your constructing understanding, which is part of your development of your lesson, the middle part. And the last C, consolidating learning, is part of your closure of your lesson planning. And then the 1E is your enrichment, which you can use for students who are more interested, students who are more capable, students with different interests.